Draft physics video. Yes, again, some more. I thought the last video was fairly good. Actually, it's an overview video. Uh, Not very exciting though. I didn't have much energy, and I don't have much tonight either. So probably should make these videos some other time at night. But I actually think I made that one. Oh no, that was the night. Anyway, sorry. I digress often. In the beginning of videos, anyway, and the end. Sometimes. Anyway, so some guy, Luke Allen, asked me to opine on a few general subjects of conventional physics kind of subjects. Yeah, my list would be a lot shorter because, I wouldn't have all these extra things. I wouldn't, there wouldn't be subjects. But anyway, because there's, physics is sort of simple, stupid. After all, who would have known? They've made such a mess out of it. But anyway, alright, so I'm interested in knowing your stance on the validity existence of the following list of physics concepts and what they represent, even if you just separate each concept into one of three categories: rational, irrational, or unsure. I'm seldom unsure. Okay, we'll go down the list. Relativity. Yes, there's relativity, but not general or special relativity. There's just relativity in the sense that you can have properties or circumstances in common with something else, and therefore the stuff that you have in common might not be noticeable to either one of you. We're being bombarded by gravity. We don't really notice the difference because we're used to it. And so you could be with somebody else who's also used to exactly the same thing. And even if they were in a different circumstance, but they were used to it, the idea of being used to it would almost be a relative concept. But the point is this: you can have the same velocity, you can have an orientation that's exactly equal but opposite, you can have lots of relationships to other things, but ultimately there's still a big frame that you're in. So there's an absolute universe, and your relative things are things that happen in the absolute universe. So you can't violate the rules of the absolute universe in your relativistic little places, your little happy relativistic places. Alright. So I don't know if I need to go. I mean, it's a broad subject, relativity, when you get into time dilation. Of course, I don't think it's for the same reasons they think it happens. Time doesn't actually dilate, just perception, all that kind of stuff. Alright, time as anything other than a measurement. Well, it's obviously more than just measuring it. It's, there wouldn't be anything if time wasn't measurable. So it's more significant than just being a measurement. It's a function of matter, and even the little bits are obligated to consume this thing called time to accomplish their tasks of moving from here to there. And because they don't do something instantaneously is why there's a universe, because if they did everything instantaneously, there wouldn't be one. So the fact that they're slow in doing things is time, and you can measure how slow, and you can make relative measurements of slowness. Ironically, the slowness is absolutely very fast for the photon, but it's still slow, right? It's slower than instantaneous. So it's a kind of slowness, ironically. Curved space. Well, the idea of space being something is kind of irritating, so the idea that somebody would invent a bent nothing is irritating, so they should have called it something else. The curved medium, the space foam, something else, but they shouldn't have said something like bent or curved space. It's just cheating, because nothing can't do something, and it's just cheating. I don't know what else to say. There obviously has to be some kind of mechanism, whether it's fairies or angels or whatever, Um, but yes, I don't think the concept is valid. I think there's actual functional little bits that might be made out of mushrooms or gremlins or fairies or Tinkerbell poo. Who knows what they're made out of? But they're distinct little things that are different than nothing. Little something bits. And those little something bits push things. And they have misperceived that as being some kind of bent space thing. The river is the space. And no, the river is actually made out of little bits of water. It's a real river. It's a real pressure field. Alright, quarks. Okay, so all of the extra bits they've shoved into atoms are all things you can't see just looking in a microscope or something, or doing common things to matter. They're not going to pop out and say, "Hi, I'm a quark." So it's the extraordinary stressing of matter before they can discover these things, these pieces. So I'm doubtful of their authenticity as real things. I think they're just like a car crash. I think they're, like fender headlights, or, the back seat flies through the windshield, and, then it picks up the battery on its way out or something. It's a combination of parts. Force bits. And they come out in a blob, and they've decided to call them something. But I'm not too sure they have any functionality in atoms, actually. But who knows? It's okay if they do. It's just that they're not really necessary to understanding, in my opinion, the basic function of the universe, which is this charge, the creation of the positive and negative charge, which creates the positive and negative pressure. Inflation. So I guess that's the part where the universe, does this little extra bit, or the part where it's still inflating. Whether there was a Big Bang or not, I don't know. We don't have conclusive evidence. We just have evidence that sort of indicates. And I'd say even the cosmic background radiation is, it's not that clear, because there's no way for me to imagine an explosion where you get to see something that happened earlier in the explosion that somehow bounced off of something. Well, what did it bounce off of? I mean, what's the radiation reflecting off of for us to see it, the echo? Echoes require something to create the echo, and they're not too clear on that part in terms of what's creating the echo, except maybe the parts that are further away, further out in the explosion than we are. Maybe. But that would mean, well, it's really hard to make an argument. I don't think inflation could also be confused with the whole idea that the universe is expanding, the space itself is expanding between everything. So you could sort of argue that if you explode something, the bits could, in a perfect explosion, you could argue, they're all going a different vector, and so they all grow distance between them, all gets bigger as they go out. And all of them will see the same thing, in the sense that they'll see everybody else moving away from them. And so they'll have this perception that they're in the center and everything's moving away from them. But that might be just because we can't see the real universe. So we're in just a piece of a ring, of like a smoke ring from an explosion. We're in the ring, and we're just seeing a little part of the ring. The real universe could be much, much huger than we understand it to be. And so our perception is just diluted by the fact that the smoke ring is expanding. But who knows? Lots of theories you can make up about that kind of stuff. Don't know if it's very important. Strings. So I imagine he's talking about string theories, and the variety of them. As I understand it, they're all basically dependent on some sort of rubber band idea. The strings really aren't strings, they're rubber bands. They're flexible things that vibrate. I mean, that part really gets silly, you know, when they start vibrating the strings. It's talking about the symphony the universe is playing, and it's, you know, it's just, that gets too silly for me anyway. It just gets too silly to even consider. Um, but yes, to me, it's a you're explaining the universe with something a million times more complicated than the universe. I mean, you know, a Stradivarius violin to explain checkers. You know, why would you do that? Why would checkers need a Stradivarius violin to play checkers? You know, that just doesn't. And the big universe has checkers written all over it. I mean, it really doesn't do anything all that mysterious, right? It's just big blobs and gravity. It just, there's really not much happening that's interesting. Now, a little bit of chemistry on each one. Yes, some of them will create different radiations and stuff, but it's just so crude, you know, mechanical. And just kind of silly to say, oh yeah, it's being controlled by the Stradivarius. No, I don't think so. Quantum mechanics, that's just, you know, doesn't mean anything. Everybody just keeps saying it like it's a thing. And it's not a thing. It's a whole collection of crap. Premises. Heisenberg, Huygens, Heisenberg's uncertainty principle. You know, Huygens, the many wave principle, the pilot wave principle, the mechanism that allows you to create all kinds of radars, you know, to give all the little dumb particles incredibly sophisticated technological perception devices. Yeah, and then probability. So, I mean, probability is a valid concept. Things have a cycle. Cycles can get changed and become erratic, and there can be probabilistic equations you can figure out. But it doesn't have to be anything mysterious, and it doesn't have to have any woo or magic in it, but they've thrown it in there. The word now is completely owned by this whole wave mechanic philosophy, and this idea of Heisenberg, this uncertainty, and nothing knows where it is, and blah, blah, blah. And so screw the word, screw quantum mechanics. It's ruined. You gotta come up with another word. Quantum functionanics. Something like that, you know. We have to just change the word in some way to just say, no, I'm talking about the quantum of energy idea and how that's valid. And you know, you could say quantum electrodynamics maybe still, because that's all that's really important, is the relationship between the little tiny bits and the electron. Quantum foam. Yeah, it's something I didn't know anything about until Hathaway mentioned it. I was like, what the fuck is that? But it's, you know, and Hathaway implied that quantum foam is just like my theory when it's based on Heisenberg's uncertainty principle and probability and randomizing and creating noise in the field. So it's not really about creating a polarized pressure gradient. No, it's about creating random noise. So it really isn't anything like my theory, and I couldn't make any sense out of it. It's just, yeah, pass. Loop-de-doo. Quantum entanglement. Yeah, another one that's just layered in just these specialty experiments. Very complex, lots of parts, lots of pieces, lots of assumptions built in about what beam splitters do and mirrors and how much you can fuck around with a light beam before you've totally fucked it. And most importantly, polarization. So most of the experiments that involve entanglement involve these assumptions about what polarization is and how well we can control it. So they have this idea that they can create these two sister photons or brother photons that are identical twins, which in itself is an assumption, and that you put them through this challenging obstacle course, and if they don't come out 50-50, you declare it magic. And I have raised the issue that polarization filters quite logically aren't going to be 50-50 if they are a mechanical mechanism like jail bars and you're trying to throw a frisbee through. And so when you throw the frisbee on edge, it goes through the bars. When you throw it this way, it doesn't. Well, the trick is that every one you throw the wrong way doesn't go through the bars. So that's a guarantee. But some of the ones you throw the right way hit the bar and bounce back. They don't get through. So it's not 50-50. So if you've assumed 50-50, you're in trouble in terms of your experiment. And I believe those experiments are in trouble. For, if not that reason, probably some other reasons. It's strangled physics. It's forcing to go beyond, I think, the limits of our capacity. The most famous experiment on the subject, I believe the guy was claiming he could count the exact photon, 18 meters away from where it was launched, something like that. That sounds like an awful extraordinary accomplishment. Yeah. Brain, I never even heard of that. B-R-A-N-E, Brain. Have no idea. Should have read the list, I guess. I have to look that one up, but I'd say it's crap. Yeah, off the top of my head. It's a crappy looking word. I can't even pronounce it. Brain. Branny? I don't know. Fuck it. Yeah, screw that. It sucks. Stupid. Irrational. Alright, parallel space. Oh, I've never heard of that either. But it's one of those space things you can be pretty sure it's bullshit. Okay, anything that's got space in it, fuck it. They're twiddling. They're playing some game with you. Okay, because space doesn't do any of this shit. Parallel nothing is stupid. So, fuck that. It's silly. Multiverse. Ooh, double silly. So this was invented for a couple of purposes. It's always just a place to throw. Well, we have too much energy, so we got to have a place to throw it. We'll just throw it into the other universe. Or if we need some extra energy, oh, well, we'll just get it from the extra universe. It's that kind of thing. So it's just contrived, completely made up. No real evidence of any kind. Just some sort of magical force that does magical things to come save the day. And I don't even understand how it even does the saving the day part, because it's all so convoluted. I can't make any sense out of the 10 universe string theory or whatever. I don't know what the fuck they're talking about. And the idea of creating universes every time a photon has a bad day, or it's just so every time a photon interacts with something, there's a new universe created. It's just silly. It's crap you can imagine, but what's the point? I can imagine a frog, wearing size 14 Bruno Mallees and smoking a cigar on a park bench. Just because I can imagine it, so what? It's just a stupid thing my brain made up. It threw a couple of shitty, stupid things together and made it up. Because you can make up this crap, and people just like hearing about it, though. People probably want a frog, that wears Bruno Mallees and smokes a good cigar. Alright, the Big Bang. Well, I covered that already. There's nothing irrational about it, but it's got problems as a theory. No matter what you come up with, the why is there something, not nothing, is always a tricky question beyond the easy answer, which is the universe doesn't have a brain, so it's probably going to do something totally, surprise, look, I made stuff. Because it doesn't know any better. It didn't make feelings on purpose. It was an accident. The universe just does accidents. Mostly train wrecks. And this is just a variety of train wreck. Alright, black holes. I would say there's black matter, you know, dense matter that isn't on fire. Sure, why not? Really heavy planets, kind of a thing. Sure, why not? Shouldn't be a law against it. Um, a sun that had some weight to it and it collected a whole bunch of crap and it clogged up the whole hydrogen engine, and so the hydrogen engine turned off. Didn't bother making no helium anymore. It just said fuck it, and just got heavy. Yeah, sure. But black hole in the sense of 7 trillion zillion solar masses, blah blah, traps light. No, none of that shit happens. You're going to fall into it and stretch and then go meet your great grandmother's, mother or something, and go back in time and shake hands or something. No. None of that. The problem with black holes is it's a hell of a lot of matter, and then you got to move matter, and and it's the whole limitation on gravity argument. Gravity has by Einstein's theory, you can go as much as you want, as little as you want, because it's made up. But in the real universe, gravity is being created by a pressure, external pressure. And the problem is you're going to run out of pressure if you make something massive enough, in the sense that you'll run out of nuclear pressure. The trick is that the pressure is still there, because like right now I'm pushing down on the Earth crust, and that's pushing on this stuff, and it's creating pressure inside the Earth. It's not gravity pressure, it's chemical pressure. It's the pressure between electrons. It's electromagnetic force that it's got converted into, because it's compressing. My mass is helping compress the core of the Earth. So in some sense you don't run out of gravity. So it's an interesting question how big you can make something, even under my theory or their theory. I'd say the fact that their theory has no bottom to the well, they can just keep going forever, just pulling that spandex fabric down another inch, another inch, another inch. I think that reveals a hole, a theoretical hole, a paradox of sorts, a dilemma, and but it is an interesting question. It seems obvious to me that there is no obvious big giant stuff in the universe, right? I mean, the galaxies are all little bits, everything's all little bits. There's no mega super planet just sitting out there somewhere saying, I am the dark planet and I'm going to eat everything in the universe. So the fact that those things don't exist likely means there's a mechanism where the pressure gets too great, the heat gets too good, and they have to fracture. They can't be maintained. So I would argue that supermassive black holes, in my opinion, probably don't exist. Dark matter, well, completely made up. I mean, the most made up thing physics ever came up with, probably. I mean, in the sense of just totally invented for the purpose of fixing problems. So it's just as Tinkerbell as you can get. I mean, the whole idea of, it's got Invisible Man written all over it, right? I mean, the whole idea of solving the case. What if Columbo showed up to solve the murder mystery? And he came up with a theory, look, this job is too hard. I mean, I can't figure this out, so let's just blame it on the Invisible Man. Okay? That's all it is. It's just, let's not fix it. Let's just invent something entirely created, just entirely made up. A new kind of matter that is invisible. That's yeah, it wasn't a joke when I was saying Invisible Man. No, it's exactly what they say. It's a new kind of matter that's invisible. It doesn't reflect anything. You can't see it. It's totally invisible. Yeah. It's really that bad. I mean, this one should make, I mean, really, professional physicists should cringe when they hear the words dark matter. They should just go, oh, gee, just don't go there, don't go there. It's bad touch, bad touch. Really bad. Alright, dark energy. So I guess that one was invented first to fix some sort of, we got too much gravity, we got to get rid of some of it, so let's have something that makes anti-gravity. Silly. Just another silly answer to a problem. Silly answer. Invisible man pushing force. Okay, fine, whatever. Silly. Antimatter. Oh dear. All of the anti things are kind of bullshit. So as soon as they say anti something, it's not really anti. So the idea of antimatter is just retarded. The antiparticles are all retarded concepts because none of them are about really antiparticles. They're really about, like, if I get out of this chair, there's an empty chair. And they're calling the empty chair I was sitting in my antiparticle. Why? Because something the same size as me will fit in it. So it's just like me, except opposite. It's just not the proper use of the word anti. Just not. So there is no antimatter. It's silly anyway. I don't know what they were saying antimatter was actually doing, but it sounds like it's just a version of the dark energy and dark matter thing. It's just another invisible man. Alright, the strong force. See, these things used to, when I was a kid, those things used to mean something I could understand. But now those words mean this whole pheromone, foogie boogie, juggy, jugga, blah, blah, blah. I mean, it's just, you can't follow what the hell they're talking about. But anyway, so the strong force for when I was a kid was basically the force between the neutron. And it's kind of the force that holds the neutron together, in my opinion, but it would be the force associated with holding protons together, because that's the function of having the neutron, is to overcome the repulsion of the protons, and so it requires a very strong force to do that. But it's basically the force of the magnet. So a neutron, it's basically the neutron force. So it's basically what happens when two magnets are stuck together. Oh, yeah, I can't even get them apart over here. So when magnets are stuck together, their force is the strongest when they actually stuck. So when you still don't let them stick, you got a chance of holding them apart. But once they're stuck, that's the strongest force there is. And that's sort of what a neutron is. It's an electron and proton that are as close as they can get. And it takes a lot of energy to push that apart. So it's basically the force holding a neutron together, in my opinion. That's what I would, if I was to use the word to describe the strong force, that's what I would call it. The force that it takes to break the neutron, which creates the the high energy of releasing protons. So the protons are in an artificially close position. If you break the neutron bond, you break the proton bond. I mean, you break what's holding the protons in the forced association. So then it becomes the opposite of what I just showed with the magnets. So if I turn the magnets to their opposite and I get that repulsion force, it's liberating the repulsion of the protons. All right, but that, the new modern physics, the Wikipedia page has all kinds of crap about quarks and this and that and blah blah blah, and who knows. The weak force, okay, so that was more like it's almost like the force of chemical bonding, but it's not electromagnetic. But yeah, that one's always been a little bit vague. So I just say it's weak. It's got weak in its name. Let's just say that's a weak concept. Let's just get rid of that and just go with this idea of the strong magnetic force, bond, and the the electromagnetic bond, which is the common bond, which is some distance. But the only two forces there are really is the attraction force, which is the absence of pressure between two things, well, not zero, but low pressure between, and the circumstance of, the reverse circumstance where you have the highest amount of reflections, or a high number of reflections. So yeah, all there is that, the magnetic force, really. Alright, the electromagnetic force is the next one, coincidentally. So yeah, that's really all of them. All the charged elements are being controlled by some form of electromagnetic force, in the sense of, you could get rid of the electro part, just go with magnetic. And yeah, that's what it's all about, the pressure, and the pressure is created by segregating the forces, segregating the positive element and its quanta from the negative element and its quanta, the black and the red, the proton and the electron. So electrons and their elements versus the proton and its elements, and that's all the forces. The God particle, the Higgs boson. So another one just layered in weirdness. So it's something creating gravity. You can't even, reading it, you just lose all will to live, because 1 minute it's a particle, 1 minute it's a field of energy, 1 minute it's it doesn't have any decent definition. And the whole idea that you have a special particle creating gravity is just silly. And so, it's contrived because they didn't give gravity a reality when they bent space. So they have to create it in the quantum world. They have to create some sort of mechanism to account for the fact that there's all this force that isn't explicit or obvious. And it's sort of like you can see the force between electrons when the black stuff is caught between it. It's doing a little ping pong ball thing. As the two electrons get closer, the frequency gets higher. You could actually have some hope of getting some representation of that. But it gets a little trickier to account for, the stuff that doesn't have anything associated with it, any strong reaction. So like a free electron would be a lot harder to see that kind of pressure, because it's going to be so subtle. So that would be sort of like maybe an excuse for the invention of the Higgs boson, but I don't know. It's, irrational. I can't say it's irrational. It's just it's not well sourced or well defended by a logically consistent theory. I don't get it. And not that I have to, but it should be more grokkable. So it's not very, I don't think the chances are high that it is some sort of gravity thing separate from. Somehow it's necessary to provide gravity. I don't know. Alright, constant of light. So that's the last one. Well, I think, of course, the speed of force. So see, this is one of the things, the minimum thing I should accomplish through all of this is maybe petitioning to have the speed of light change to the speed of force. And I think that would it'd be so much better if people thought in those terms, because it's not about the speed of what we call light. It's the electromagnetic forces, all of them, and it's the speed of gravity. So it's all the forces that we can really call a force are moving at this constant speed, the same constant speed. And I think people would have a much better understanding of the universe if they sort of understood that light is a force. It's just a nuance of force. It's a force in drag. It's a little bit different. That's all. It's doing this at a frequency thing. But it's the same crap as the forces that are moving all the other stuff, pushing it. But yes, I think the constant is reliable enough, and it's just for all purposes, for all our purposes. I don't think you can go faster than the light. I don't think it'd do you much good if you did, because I don't think you can go faster than light enough to be able to do anything real in terms of time travel or any of that bullshit. It's still not going to do you any good. You know, even instantaneous isn't going to do you much good. In terms, because, you know, you'll pass the future you're trying to get to if you could keep instantaneousing. If you kept instantaneousing. Well, anyway, I just mean it's not, to me it's not a meaningful subject, is all I'd say. And beyond establishing the fact that there's a quite reliable consistency between all of the forces and even the big matter and how it functions, and it all relates to this speed of the little bits. There's a certain relationship. And yes, some of that looks confusing when people say light slows down in going through glass or through water. And, you know, a little bit of intelligence applied to that, and you can understand that it doesn't really, that it's just traveling the longer path, whether it's a this or whether it's a bing, 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 or it's just a longer path. Transparency doesn't mean light just goes right through it. Glass is heavy. It's full of atoms. You're not, you know, if you think you're going through a bunch of empty space in the glass, you're not thinking very hard. Alright. After that, I'd like to know if you agree or disagree with that orthodox science does not know the causation of magnetism, gravity, motion, solar energy. Oh, that's kind of weird. Solar corona. Why would I even worry about that? I think they understand some of the nuclear products produced by the sun fairly well, so I think they understand that, you know, I mean, look, it's pretty hard to understand something that's a billion Kelvin or something. You don't get every bit of it right, but I think they generally understand the thermodynamics of the sun, so I wouldn't agree that that deserves to be on the list. Solar energy, I don't even know why. I mean, we're getting better and better at that all the time, in terms of increasing our ability to grab more efficiency out of sunlight. But I don't think there's anything magical about it. You know, I mean, trees figured out how to do it. It's just mechanics, you know, very small mechanical devices, very, very small. So I wouldn't put that in the category of science doesn't know what it's getting there. Motion, yes, they haven't paid any attention to the concept of inertia and the acquisition of velocity and what it means to keep moving through space. That actually means something has changed about you, that you keep doing that. That, you know, it's not just some magical force that just means that once I'm going, I just keep going. It's not to keep going. There's something physically different between me sitting here and me going 50 miles an hour in a direction. That's an added direction, you know, my absolute velocity, so to speak. Those two me's are not the same physical me. And one of them will actually weigh more. So we sort of know that. But you can sort of surmise that out of the fact that wherever it's going is where its matter, its mass is heading. And so the faster I make it go, the more mass it has in the direction it's going. So give it more and more velocity and has more of its mass is in this dimension, and less of its mass are in these other two dimensions. And that seems quite obvious. Things almost seem to disappear as they go faster and faster. No, it's not a coincidence, because they sort of are disappearing in these dimensions. Alright, so yes, but I agree they have no clue on they just don't get it, that it's a something, the two things are different. The thing not moving and the thing going 50 miles an hour, they were the same thing through space, let's say. The two things are different physically. One of them is in a different configuration, and that's why it keeps moving. It contains force. Alright, gravity. Well, they have their theory, yeah. Obviously. I mean, it's kind of silly to say, I certainly disagree with it, but I would not agree that they don't know. They just have a completely silly and stupid answer. And magnetism, yes, they haven't tried nearly hard enough. I mean, they just, you know, it screams for an answer because it's so related to gravity that you think, you know, has so much in common, and the Maxwell equations and everything. You just think somebody would have said that no, you know, answering this question is the big one. Because you know you have to come up with a place that the force is coming from. You can't just pretend that the magnet has perpetual motion machines inside of it and it's just somehow generating this magnetism. And that's where they broke the game, was when they made gravity bent space. Well, then they couldn't use that force to create magnetism, because that's all magnets are doing. They're just filtering gravity. It's just so obvious in hindsight. But I can say I always knew that magnets were, I was always fascinated by magnets. Not that everybody isn't, but I mean, I saw them as the physics Rosetta Stone. If you could understand that, you could understand everything else. So I sort of thought of it that way, because it's so obviously screaming for an outside answer. Where's the force coming from? The magnet isn't getting hot. The magnet isn't using any energy. How can it do something, create magnetic fields, when it doesn't use any energy? The answer is the energy's got to come from somewhere, right? But like I said, it's just like the Einstein answer that was always so empty to me. Because it's clear, this idea of space moving huge giant planets around, no, that takes energy. Where's the energy coming from? Alright. What matter is made of, and why does it do what it does? And why it does what it does? Well, now, I mean, again, does not know. I just can't say they don't know anything. They know some stuff. They just don't know. They have some bad axioms that they just keep, you know, they have some poorly placed horses, and they, you know, they're going the wrong way. You got a horse tied this way and a horse tied that way, and, you know, they've made a few mistakes in how they've organized this thing, and so their theory isn't coherent. And but they have elements of it. What energy is made of and why it does what it does. So again, it's not really energy. You know, we all use that word, but it's just imbalances in force. So that's something to understand. I mean, energy is just revealing an imbalance in the force. It's an imbalance in pressure. Obviously, they don't seem to think so in any dramatic way. So I'd say yes, they have little clue regarding the nature of energy and why it's conservative. It's conservative because there's equal amounts of stuff going this way and this way. So if you're using up some stuff going this way, the rest of the stuff going that way has to be showing up somewhere else, because you've made an imbalance. If I take a bunch of stuff going this way and I hide it over here, well, all the stuff going this way is now loose. There's nothing going this way to stop it anymore. So the stuff going this way is going to show up somewhere. What is the most abundant thing in the universe? Well, obviously quanta. If your question is in some other context, I don't know, hydrogen? I don't know. I don't know the nature of the question. It's, what is it, some kind of trick question? Roughly how much more abundant do you think that thing is than everything else combined? Well, the quanta is about, compared to the matter, yeah, it's like a bazillion times more. Bazillion times. Bazillion. Yeah, I like that. Bazillion. Could be a gazillion, but I think it's bazillion. Do you think we have a good understanding of what a good understanding of that most abundant thing? Well, I obviously have a a much improved understanding of late. So I guess we don't. Do I think we? No. As a we don't have a very good understanding of the quanta. But like I said, I'm doing pretty good. Alright. So I don't know whether this was a troll comment or what it was. Teachers have told me that light bounces around in the glass, taking a longer path, but somehow all those ricochets resolve to the transmission. Well, that's right, because the atoms are all whole, So whatever happens at one end, it has to vibrate through a very, always an even number of things. And so it'll always leave like it came in because there's a rigid consistency to the ricochets. And so then he says, rate of induction, and then he does a D, smiley thing, I guess. I don't know if it's a winky smiley. I don't know what the hell that is. Rate of induction. Yeah, so that's Ken Wheeler's blah blah. So I don't know whether he's laughing at Ken, but whatever. Or me, or whatever it is. Yeah, I mean, sorry, but, people, you write comments sometimes, you're being a little, your sarcasm isn't clear. So sometimes it's hard to know who you're making fun of. Spin magnetism is magnetism. So, I don't know, that sounds like a Ken Wheeler kind of thing. Oh, these were probably on a Ken Wheeler video, sorry. Microscopic units are toroidal quanta of the gravomagnetic field, which is indistinguishable from magnetism, but it's twisting. Just saying, long time no see, get it? I don't know. I don't really get it, but obviously hyperborealoids and toroidal blah blah, I don't think have much place in these conversations. I mean, they're real concepts of geometry, but I don't think they have much to do with anything that's happening in the universe. So some guy leaves a link to, thank you for your brilliant analysis. Sounds patronizing. Something from chronology of the world. So why do I need chronology of the world? Yes, humans have made mistakes in the past. That doesn't mean that everything they say is wrong. I'm so sick of people. Alright, you called idiots, retards, etc. anyone in your comment section, which probably they are, so why you debate with idiots? Well, I have to deal with what shows up. And yeah, if it's just an audience full of hecklers, well, that's all I get. If you debate with idiots after some short period of time, neutral observer wouldn't be able to conclude who the idiot and who is the genius. Well, the neutral observer through this process has to have some sort of capacity, competence to understand some pretty complex physical concepts. And So they're going to have to really be paying attention and give a shit, because physics really isn't tinker toys and shit. I mean, I certainly can simplify it, and I can try to explain that the universe is a lot simpler than the physicists are talking about. But I certainly can't deconstruct for somebody what they believe without having to get into an awful lot of complexity, because their theory is very complex. So, so what's your expectation? The neutral observer, in my opinion, should be able to figure it out. Who, when they see Piro present distorted evidence, when they see these, people redundantly saying something like, the sage gravity was disproven 100 years ago, blah, 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 blah. When disproven is not what it was done. It was debunked casually, superficially. And I'm not arguing it. So, I mean, they could see that it's a straw man, because I'm not arguing Lesage or Lafreniere, whatever his name was, gravity. I fixed it. It's a new thing. It's got quantons in it, polarized quantons. I mean, it's a lot different. Okay, it's not just ultramundane particles. It's ultramundane particles that are polarized. I mean, it's a different theory. And yet somehow it's proof that my theory's wrong, because somebody else's theory wasn't 100% correct. My theory is now wrong because you proved his theory wrong. Now, I'm just saying, if somebody, a neutral observer, isn't smart enough to figure out I won that argument, then what's the point? There's no, I have neutral observers are going to be useless to this website then. I mean, if they can't figure out who's right and wrong on that. Alright, I don't think there's any other, there's probably some other stupid troll comment, but I don't think it's worth it. Too slick video, hard to play a laser pointer, implausible amongst virtual, weird dilation. Yes, they're all full of shit, that's right. Alright, and so, some James guy did ask off topic, is there anyone out there that would like to weigh in on how to read phase diagram? Yeah, my only understanding of them, it's really talking about, gas, liquid, solid. And the factors that decide that are this idea of temperature and air pressure, or surface pressure. And what the pressure really is, and so really, ideally, you just have straight lines. You go straight across for the pressure, this much pressure, and this much temperature, and you'd be either in a region that was solid, liquid, or gas. But it gets fudgy for each material because of, the chemistry is cascade kind of chemistry. But I think so all it really is about either fall in the region of this is what it's going to likely be. Now, it would be a certainty if you knew that everything in the body was exactly the same temperature, and it was the same temperature for a long enough period of time. Then you could say everything was frozen, or everything was liquid, or everything was gas. But the trick is that you can't do any of that, because even cosmic rays or something will affect one tiny atom in there and change it to a liquid from a gas, or from a gas to a solid, or something like that. So that's my understanding of why the charts are useful. It looks kind of messy to me. I mean, it's a messy way, in my opinion, to arrange information in these regions. But it's really just saying, you follow the guidepost, and the guidepost will tell you that the further you are in a region, the more likely it is the thing is solid or liquid or gas. And the closer you are to a line, the more you are in a mushy area. But that's my interpretation. Sorry, not enough people are going to know what the hell I was talking about there. Sorry, I should have paid attention to the off-topic part. But anyway, the point I wanted to raise, the reason why I brought it up was just because he gets all this harassment from this David Bernhardt Benatar? Oh, so he's going by a fake name. Oh, well, I'm just going to block him. Yeah, right. Fuck that shit. I'm so sick of these fakers. But all this harassment from a troll. I mean, 10, 15 comments. You know, so they even harass the commenters in the videos. I mean, it's just... So some asshole, I'm sorry, you might be a nice guy, but badass motherfucker calls himself. Fuck you. Stupid name. I always thought quantum entanglement was bullshit. Apparently some physicists even think that time travel is possible. Yes, well, they're idiots. Yeah, past is really dead. It's really, really... If you actually go to the past, yeah, it's just going to be a skeleton because the past is dead. And the future ain't born yet, so it just ain't going to happen. Here's one particularly moronic fool who claims that the photon goes back in time and changes the wave back into a particle again. Yeah, well, there's no waves associated with particles. There just aren't. A whole group of particles can create a wave, but the particles themselves have no wave function. Alright, so that's enough, I believe. Sorry, another long video. I thought it was worth doing. So some of it might, I don't know. I mean, it really wasn't. Yeah, it might be. Couldn't hurt. But I apologize if it did. If it hurt, I'm sorry.